In the previous discussion, we discussed how to solve oblique triangles using law of sine. In some cases, you cannot use the law of sine to solve oblique triangle. So in order to do that, we will use another formula, which is law of cosine. The law of cosine can be used in the following situations. First, if you are given a triangle with SAS, meaning you are given side, angle, side, or you are given two sides and an included angle. Remember, the angle must be between the two sides given. You can also use the law of cosine if you are given three sides. We can also use law of cosine if we are given three angles. Okay, so these situations will be discussed later. For any triangle ABC, wherein A, B, and C, which are the uppercase letters or capital letters, represent the angles of a triangle, and lowercase letters or small letters A, B, C are the sides of the triangle. We have here different formulas in order to find the length of the side of any given triangle. If you want to solve for A, B, or C. If you notice, the left side of the equation are squared, which is A squared, B squared, or C squared. In order to finalize our answer, we need to get the square root of the equation on both sides. So after solving for this one, you need to get the square root of both sides of the equation to get the length of any side of a triangle. If we want to solve for an angle, we will just derive the formulas given earlier and we can come up with this formula. Suppose we want to solve for angle A. Therefore, our formula will be cosine A equals B squared plus C squared minus A squared all over 2BC. But remember, whenever you are using your calculator, you need to press shift cosine on your calculator in order to get the desired angle of the triangle. Now let us use those formulas in solving for these examples. Okay, so let me just solve for number one of both tests. Okay, so in first set, we want to solve for the length of the missing side, while on the second set, we want to solve for the specified angle. So let us just answer one examples from each set, and the other examples, you can try it on your own. Okay, so let us solve for number one. You are given angle C, which is 115 degrees, side A, which is 11, and side B, which is 21. Now let us represent the triangle. Suppose this is our triangle. Since we are asked to solve for the missing side, it means that we need to solve for side C, which is opposite of the given angle, which is angle C, and that is 115 degrees. Using the formulas that we have earlier, we can use C squared equals A squared plus B squared minus 2AB cosine C. And then let us just input the given values into our formula. So that we have 11 square plus 21 square minus 2 times 11 times 21 cosine 115 degrees. Solving for each value one by one, the square of 11 is 121. The square of 21 is 441. And then 2 times 11 times 21 is 462 cosine 115 degrees. Adding 121 and 441, we'll get 562. And getting the value of 462 cosine 115 degrees, that will result to negative 195.25. So now we have 562 minus negative 195.25. So it means that in order to simplify this, it will become 562 plus 195.25. Performing the operation, we'll have 757.25. Now, since the value on the left side is still squared, we need to get the square root both sides. So it will become C is equal to the square root of 757.25. Therefore, our final answer should be 27.52. It means that the length of side C is 27.52. If you are using a natural display calculator or a scientific calculator, you can input directly all the values into the formula. So meaning, you can just show the solution, the first line or the second line. And then you will arrive already at the final answer. Or if you want, you can already include the square root sign, square root symbol on the first line of the formula so that at the end you will arrive at 27.52. So that is how we solve for the side of a given triangle using law of cosine. This time, let us solve for the missing angle or the specified angle. So here we are given three sides of the triangle, which are A equals 11, B equals 14, and C, which is 17. And we are asked to find angle A. Now let us represent the triangle. Suppose our triangle is represented this way. Remember, a side is always opposite to the angle. So this is side A, which is 11. This is side B, which is 14. And this is side C, which is 17. And then we want to solve for angle A. Using the formula that we have earlier, we'll have cosine A equals B squared plus C squared minus A squared all over 2BC. Let us substitute the given values so that we have 14 square plus 17 square minus 11 square all over 2 times 14 times 17. Performing the operation, we'll have 196 plus 289 minus 121 all over 476. In order to get the final answer, we'll press Shift Cosine and then let us input these values in our calculator. So Shift Cosine and then input 196 plus 289 minus 121 all over 476. Therefore, you will arrive at 40.12 degrees, meaning the value of angle A is 40.12 degrees. So that is how we use the law of cosine in solving for a specified angle of an oblique triangle. Now let us have some of applications. So this time let us use the law of cosine in solving this kind of problem. So let us read the problem first. The east end of Silver Fund is 5.6 miles from the intersection of Hennick and Knott Road, and the west end is 3.2 miles from the intersection. If the two roads are straight and intersect at an angle of 74 degrees, what is the distance from the west end to the east end of the fund? Now let us represent the triangle. Suppose this is our representation, wherein the east end is 5.6 miles, the west end is 3.2 miles, and the angle of their intersection is 74 degrees. We are asked to find the distance opposite of the given angle. Let us name that side as side C. Now let us use the formula in finding the length of a side in law of cosine. So let us have c squared equals 3.2 squared plus 5.6 squared minus 2 times 3.2 times 5.6 cosine 74 degrees. So simplifying the formula and getting the square root already, will arrive at 10.4 plus 31.26 minus 9.8, or the square root of 10.4 plus 31.26 minus 9.8. Therefore, our final answer should be 5.62 miles. Again, in order to answer problems like this correctly, you must illustrate the problems correctly. So you need to understand and visualize the problem first. So this second problem, you can try it on your own and answer this problem. So here you are given the wingspan of a jet, the intersection of the wingspan, which is 109.05 degrees, and you are asked to find the wingspan from A to C. Let's say the length of this side is 105.6, therefore the other side is also 105.6. The angle of intersection is 109.05 degrees. And we want to solve for this wingspan. So you can use uh, a formula that we have used earlier in finding the length of the side of this triangle. Another application of a law of cosine is finding the area of a triangle. Remember, the general formula in finding the area of any triangle is 1 half times the base times the height, wherein the base is the horizontal distance of a triangle. Okay, so you can usually find it below the triangle. And then the height is the perpendicular distance from the base. So if you know already the base and the height, you will just use this formula, 1 half times the base times the height. But in some cases, you will not be given the base and the height. Therefore, we can use the law of cosine to find the area of the given triangle. Please take note of this triangle. Suppose you are given angles ABC and then sides A, B, and C. So here our base is C, and then the height is the perpendicular distance from C, which is the base. So by looking at the triangle, we can simply solve for the height using angle A and side B. So here, we notice that we have a right triangle here. Therefore, we can use the formula for right triangle given angle A. So that will be sine A equals opposite over adjacent, or over hypotenuse. Again, that is sine A equals opposite over hypotenuse, wherein the opposite side is h, or the height, and the hypotenuse side is b. So simplifying the formula, we will arrive at this formula in finding the height. Therefore, the height is equivalent to b sine A, wherein b is the hypotenuse, and then A is the given angle. And then from there, we can formulate our own formula in finding the area. Remember, our base is side C, and height is equal to b sine A. So therefore, arriving our formula using law of cosine, the area can be solved as 1 half times C, wherein the base, times b sine A, which is the height. So we can use either 1 half base times height, or we can use area is equal to 1 half times C times B times sine A. Remember that C and B are interchangeable because we are dealing with multiplication. If we were going to use other sides and angles, we can arrive at this formula. So let us take note of the pattern. So the first formula is 1/2 of side A times B sine C. Remember, C is between A and B. So that can be 1/2 of A, B sine C. Another formula that we can use is 1/2 of C, A sine B. Again, notice that the angle is between A and C. So given two sides and included angle, we can always find the area of a triangle by just taking note of the pattern. Again, that is 1/2 of AB sine C, or 1/2 of AC or CA sine B, or we can also use 1/2 of BC or CB sine A. So there are three different formulas that we can use. Now let us solve the area of these triangles. Let's start with the first one. Since we already have two sides and an included angle, wherein the angle is between the sides given, we can already use the formula that we have discussed earlier. So to find the area, our formula now will be 1/2 of 12 times 24 sine 127. Again, you can interchange 24 and 12. So you can write 1/2 times 24 times 12 sine 127. Or you can also write 1/2 times 12 times 24 sine 127. So again, you can interchange 12 and 24. Anyway, that is multiplication. Therefore, the final answer will not be affected because multiplication is commutative and associative. So solving for this one, we will arrive at 115.003 square units. Remember that we are solving for the area, therefore our final answer should be always in square units. Or that is approximately 115 square units if we were going to round it off. So we can easily find the area of the given triangle if we already know two sides and an included angle. Now let us have an alternative solution, which is a step-by-step solution for this one, or a different solution, which is longer. Using the same given, we'll have side 12, side 24, and then angle 127. Remember that the area can be solved by getting the height and the base. So we need to identify the height and the base. So the base is the perpendicular distance. The base is the horizontal distance, while the height is the perpendicular distance from the base. So let us solve this step by step. First, let us solve for the base. We can easily solve for the base using the formula that we have in Law of Cosine. So to do that, we can have this formula. So the base is equivalent to the square root of 12 square plus 24 square minus 2 times 12 times 24 cosine 127. So solving for this one, we can say that the base is 32.66. So let us put the value of the base, which is 32.66. Next step, let's solve for the missing angle. Let us name the missing angle as x. So using law of sine, we can use sine 127 degrees over 32.66 equals sine x all over 24. So simplifying this equation, we can have sine x equals 24 sine 127 degrees all over 32.66. Again, in order to solve for the value of x, which is an angle, you need to press shift sign on your calculator. So press Shift sign and then enter the values, which are 24 sine 127 degrees all over 32.66. Therefore, the value of that angle is 35.94 degrees. So x is equivalent to 35.94 degrees. So now let's put that value on x. So next step, let us solve for the height. So to find the height, we can just use the right triangle formula. Remember that the height and normal and the horizontal distance are perpendicular, so we can form a right triangle there. So the height can be solved by using sine 35.94 degrees equals the opposite side, which is the height, all over the hypotenuse, which is 12, based on the right triangle that we formed here. So this is our right triangle. So simplifying the equation, we can have height is equal to 12 sine 35.94 degrees. Therefore, the height is approximately 7.04. Now let us put that value on height. So since we have already find the height and the base of the triangle, we can now find the area. Remember, the area is 1/2 of base times the height, wherein the base is 32.66 and the height is 7.04. So area is 1/2 times 32.66 times 7.04. And that is approximately 114.96 or 115 square units, which is similar with our answer earlier. Remember, there are deviations because we already rounded up our previous answers earlier. But if we're going to approximate it into nearest whole number, the answer is still the same, which is 115 square units. So either you use the longer solution or we can use the shorter solution that I have presented earlier. Now let us answer the second given. So we are given a triangle with angle which is 76.3 degrees and another angle which is 42.8 degrees and a side which is 17.9 or 17.9. If we will going to change the position of the triangle, so we can change it like this way. This is angle 76.3 degrees and this is another angle which is 42.8 degrees and this is the side which is 17.9. So here we can say that the height is this one and this will be our base, which is the horizontal distance. So now let us solve this triangle step by step using the new position of the triangle. So we just rotated the triangle, but we did not change any value. So first, let us solve for the missing angle. We already have two angles given, and we can easily solve for the missing angle. Let us say that that is angle x. So we can just add the two given angles and then solve it from 180 degrees. Therefore, the missing angle is 60.9 degrees. We can we cannot directly use law of cosine to solve for the area because the given angles are not between any two sides. We can only use the direct formula to find the area using law of cosine if the angle is between two sides given. But in this triangle, we only have one side and two angles. So we cannot directly use the formula given. So we need to solve this step by step. Therefore, the missing angle is 60.9 degrees. Next step, let us solve for the base. So to solve for the base, we can use law of sine again. So to do that, we can use the given angle and its opposite side, which is 76.3 and 17.9. So that will be sine 76.3 degrees over 17.9. And then since we want to solve for the base, we can now use 60.9 degrees. Therefore, the formula is 6 sine 60.9 degrees all over the base. Simplifying the equation, we can say that the base is equal to 17.9 sine 60.9 degrees all over sine 76.3. Therefore, the base is 16.1. So now we already have the base. Let us solve for the height of the triangle. Notice that we have here a right triangle, wherein we already have the hypotenuse of the right triangle, which is 17.9. So this will be our right triangle. The hypotenuse is 17.9. We are already have a given angle here, which is 42.8, and the opposite side, which is the height. So to solve for the height, we can use the formula in solving right triangle. Therefore, the formula will be sine 48, 42.8 degrees equals the opposite side, which is the height, all over the hypotenuse, which is 17.9. Simplifying the equation, the height will be 17.9 sine 42.8 degrees. Therefore, the height is 12.16. Now, we already have the height and the base of the triangle. We can now solve for the area of this triangle. Remember, the area is equal to 1 half equals base times height. So let us substitute the values given, wherein the base is 16.1 and then the height is 12.16. So the area is 1 half times 16.1 times 12.16. Therefore, the area of this given triangle is 97.89 square units. So that is how we use the law of cosine in solving for the area of the given triangle. Now you can try this problem. So you need to solve for the area first before you identify the cos of the triangular line given the dimensions. So we are already done discussing law of cosine, law of sine, and solving right triangles. That's all. Thank you.